Has anybody heard of IGMP?
Maybe. Maybe I've heard it.
Sort of, maybe?
Maybe.
Potentially, sounds familiar. And if it is what I think it is, I could be wrong.
Is it Internet Group Management Protocol?
Bingo.
Good job.
Right.
Good job, man.
Yeah. I wonder, what were you gonna say? The same thing?
No, that's not what I was gonna say.
I was gonna say, is it how the administrator of a network controls, say, what sites you can go to and what sites you can't.
That would be DNS filtering, right?
That's one way to do it.
Pretty sure it's like additional software you can use to just straight up.
IGMP is actually a way for the network to automatically control broadcast storm by using multicast instead. So you have all of your hosted devices and the router talk to each other, and they figure out who is in a specific group. Like you're running voice over IP phones, then you only need to send VoIP traffic to the phones. You don't need to send it to all the computers and the tablets and things like that on the network. Conversely, if you are streaming video, bless you, streaming video on say Netflix, or if you're running your own media server like Plex or MB, or I run Jellyfin, got the smart TVs in the house, but the computers don't need to have access to the, bless you, to the
Roku.
streaming.
To your Roku, basically.
Yeah,
It doesn't need access to it.
well, the Roku would have access to the streaming,
Right.
but you wouldn't need to send the voice over IP data to it, right? Okay, so anyway, IGMP helps routers and smart managed switches, the ones that have some intelligence built into them, how to direct network traffic, so only the hosts that need the traffic or want the traffic actually get it. So you're not just blasting everything out over every port on the switch. Only those who are interested in receiving multicast traffic get it. Okay, cool.
What is multicast traffic? Have we talked about this?
A little bit, yeah. Unicast is just you and I. Multicast is me and everybody on that table. Broadcast is me and everybody in the room.
I see.
So the IGMP makes your network a lot more efficient. Rather than me having to send unicast traffic to Ethan and then to Nate and then Drew and then Ty and Mike and then to you, I can just do my multicast and say, hey, guys in the group, here's the information you want to know.
So like, let's say like these three guys are like TVs. You're saying kind of like your TVs are the ones that need to know about Jellyfin, but your printer and your Google Nest doesn't need to know about.
Right.
Okay.
So it's a way to minimize congestion on your network, makes it a lot more efficient. If you have everybody talking to everybody at the same time, you see where it can become a problem.
Yeah.
Especially as you start adding devices to your network. there are other ways to segment it, like VLAN, which we're going to talk about later in the semester. These don't want to talk to each other at all, but everything still goes back to the router. So it's primarily, IGMP is primarily for IPv4. If you do IGMP on a V6 network, it's actually done by multicast listener discovery, or MLD, instead of IGMP. Like other network protocols, IGMP is used on layer 3. That's layer 3 of OSI, so the network layer. Multicast listener V1 is almost exactly the same as IGMP V2. MLD V2 is almost the same as, it's almost similar. Not quite similar, but almost similar. IGMP V3.
That's funny. Fixing to get ready.
Yeah, fixing to get ready. IGMP V1 was developed way back in 1989 at Stanford University. The bigger your network is, the more important it becomes. V1 was later updated to V2 in 97, and again in 02 to V3. It was used by the hosts and routers to identify which hosts in the LAN are members of a group. So if I am a member of the streaming group and generic group, I guess, then I'm going to say, hey, router, any traffic that you have for streaming or generic, I want to know. And then it says, okay, no problem. If that happens to come across, it just routes it out that port. IGMP is encapsulated in an IP datagram. Datagram is self-contained, independent packet transmitted across the network without a guarantee for delivery. Think UDP, User Datagram Protocol. The connectionless, which means that it's, I send it out there, if you happen to get it, great, if not, don't care. Bad thing about UDP is the packets can arrive out of order, or not at all, or multiple times, because there is no handshake that says, hey, I want to tell you something, okay, what is it? Here's what it is. This is what you told me, yes, so on. It's just put it out there, you get it, great. You get it more than once, great. I say the dog ran, it might get to you as the ran dog, out of order, or just the dog. Okay, what about the dog, right? That's basically UDP. IP supports two different types of communication: unicast, which is communication between one sender, one receiver. We can say it's one-to-one. There's the answer to your question. Cool. Multicast, sometimes the sender wants to send the same message to a large number of receivers simultaneously. Multicast, which has one-to-many communication. Applications, streaming, multicast is used for audio, video streaming over network. One-to-many or many-to-many. Anybody have a guess on what many to many would be?
Like a limit party. That's like many people talking to many people.
Yeah. But,
That kind of doesn't make sense.
No.
That's like the girls at my school. Many of them are talking to many people at once and they're trading boyfriends and there's
Well, Manny,
boyfriends dropped off the roster sometimes.
Kind of like unicast.
Manny, like on Teams.
yeah. But that's a good analogy.
What did he say? I'm sorry.
Teams.
Oh, teams. Oh, okay, that's what I thought he said. I wasn't
Yeah.
sure.
Zeus, or whatever the other ones are.
Zoom,
Yeah.
Right. Yeah, that's a good.
I've heard of Zeus, but I don't know what it is.
Yeah, I don't either. I think I was thinking of Zoom.
Yeah. Anybody know what Zeus is?
Zeus.
I think it's a dating app,
Oh,
but it sounds
oh,
so.
a bit many to many.
Yeah.
Lightning.
If you happen to have more than one, server, like Netflix, millions of subscribers, they don't have just one
Right.
server that's serving everybody. They've got, dozens, if not hundreds of servers in their data center,
Probably the size of this building.
at least. Gaming is often used in simulation games, online, shoot 'em ups like, WoW, Fortnite, what's the new Minecraft? Yeah, those kind of things. Do you younger guys know what WoW is?
World of Warcraft.
Yeah,
Yeah.
famous.
What'd you say?
I said I was very addicted to it.
Yeah.
Web conferencing, which is the Zoom or Teams or whatever. 3 types or versions of IGMP. They are backward compatible. V1 was the original, allows all supporting hosts to join the multicast group using a membership request that includes some basic features. Host cannot leave the group on their own, have to wait for a timeout. So if you're done streaming, you can't just say, see ya. You're going to continue to get that traffic until such time that your membership expires. That way I don't have to refund you the difference on your subscription that you didn't use. Version is set to 1. Type set to 1. Host membership query and host membership report are the only things in there. There are 8 bits of 0, which with no use, it's marked unused. Checksum is a way to be relatively certain that the data that was sent is the data that was received. The checksum is calculated when the packet is sent, and then whenever you get to the other end, you disassemble the packet, run the same algorithm on it, check it against the checksum. If it doesn't match up, then you didn't get accurate data.
So it uses those 8 bits of 0 just to make up the 32-bit address?
Yeah, it is just filler. Group address field. The group address field is 0 when sent and ignored when received in membership query messages. Membership report message, the group address field takes the IP host group address of the group being reported. So group address may or may not be zeros. V2, revised version of V1 has added functionality of leaving multicast group. Multicast packet format in V2 looks like that. Type field, if it is 11X, membership query. 1.2 is for a V1 membership report. 1.6 V2 membership report. 2.2 for a V3 membership report. And if you have 1.7 in there, you say bye. See ya. Max response time, just how long you're allowed to respond. Checksum works exactly the same way as it did in the other one. Group address, set to 0 when sending a general query, but unless it has multicast address for the specific group. Membership queries, group address is set to 0 for a general query. Sets multicast for a specific query. For membership report, the group address is set to the multicast group address. For leave group, set to the group multicast group address. V3 added a whole bunch more functionality over V1 and V2. So notice that V1 is 8 bytes to 32-bit words. V2 is 2 32-bit words. When you get down here into V3, whole lot bigger multicast traffic. Okay. Added source-specific multicast membership report aggregation. Reports are sent to 224.0.0.22. That is part of the Class D address space, the reserved special use addresses in IPv4, and it is specific for V3 membership reports. IPv4 uses this address in routers listed for IGMP set by the hosts, and it's when they ask to join or leave a specific multicast group.
On V3 and V4, do they have to wait for the subscription to end, or can they just leave?
There is no V4.
Oh, I'm sorry, IPv4. Version 3, is there, can they leave when they want to, or?
Yeah.
They don't have to wait for permission? Okay.
V1 is the only one that you can't.
Oh, V1's the only one that requires permission, okay.
Your membership has to time out,
In
basically.
V1, okay.
Yeah, V2, V3, you can leave whenever you want to. IGMP helps manage multicast group membership in an efficient way, ensuring that only relevant multicast traffic is delivered to the hosts that request it. Part of the reserved IPv4 multicast range, which is used for network control purposes. And that's what the V3 packet format looks like. So basically 0 through 7, first 8 bits is the type. Next 8 bits is the response code, and last 16 are the checksum. Next 32 is the group address. First 4 and the third word is reserved. The S flag represents suppress router side processing. When flag is set, indicate to suppress the timer updates that multicast routers perform on receiving any query. QRV is the querier's robustness variable. Do you guys have a robustness variable? I don't.
I wish I did.
Wouldn't it be nice?
It would be nice.
Yes.
I could just turn it up right now.
Crank it to
down.
11.
I have to keep mine toned down, otherwise it'd just be too much for
Yeah.
everybody.
Right on.
I like the spicy variables.
The spicy variable. Wish I could turn that down on my sister. Holy cow.
Your sister spicy.
Pretty much. I mean, she's speaking Spanish now and stuff because she likes it, I guess.
Because she can.
Because she can, and she uses it all the time. I'm like, shut up. Like, stop.
Well, that's the best way to learn it.
Yeah, she's really good at it though.
QQIC, query interval code. And then number of sources, by represent number of source addresses present in the query. For general query or group specific, field is 0, and for group and source specific query, the field is set to a non-zero value. Source address represents the IP unicast address for N fields. N is just the number of fields for, that are listed in the number of sources. Okay. IGMP works on devices that are capable of handling multicast groups and dynamic multicasting. These devices allow the host to join or leave membership in the multicast group. Also allow to add or remove clients from the group. Common protocol is operated between host and local multicast router. When multicast group is created, multicast group address range of 224 to 239 is used and is forwarded as a destination IP address in the packet. So client talks to the router, goes to multicast router, level 2 switch, and then to the host. This is IGMP snooping. Here where it says it. Level 2 devices such as switches are used between host and multicast router for IGMP snooping. Snooping is a process to listen to the IGMP traffic on the network in a controlled manner. Switch receives a message from the host and forwards the membership report to the local multicast router. Multicast traffic is further forwarded to remote routers from local multicast routers, including PIN or protocol independent multicast. So the client can receive the message and data packets. Clients wishing to join the network sends a join message to the query, and the switch intercepts the message, adds the port of the client to its multicast routing table. Advantages: IGMP efficiently transmits multicast to the receivers, so no junk packets are transmitted to the host, which shows optimized performance, also prevents it from sending the packets to people who are not interested. Bandwidth is consumed totally as all the shared links are connected, and hosts can leave and join a different multicast group if they choose. Disadvantages: doesn't provide good efficiency in filtering. Due to lack of transport control, network congestion can occur, and it is extremely vulnerable to DDoS attacks. So what is snooping? Method that network switches use to identify multicast groups, which are groups of computers or devices that all receive the same network traffic. Enable switches to forward packets to the correct devices in their network. Is a network layer protocol allows several devices to share one IP Because everybody listens to the Class D stuff. Network devices use IGMP to jointly multicast group, and each multicast group shares one IP address. Most network switches cannot see which devices have joined since they don't process network layer protocols. Remember what layer of OSI switches are in?
Layer 2, aren't they?
It's layer 2. IGMP works network layer, which is layer 3. So you have to have a switch that is specifically designed to do IGMP snooping in order for it to work correctly. Snooping is a way around. It allows switches to snoop on IGMP messages even though they technically belong to a different lane. So snooping provides several key benefits: efficient multicast traffic delivery, improved network performance, limit multicast traffic, conserves bandwidth and congestion, enhanced security, restricting multicast traffic to only relevant devices, reduces the exposure of multicast data to unintended recipients, makes minimizing the risk of unauthorized access. So since a device can request IGMP membership, I don't know of any mechanism that would allow the IGMP router to know who's legit and who isn't. Optimize resource utilization. Network devices such as switches can better allocate resources, like the CPU and the memory. When required traffic is handled, improving the overall efficiency of the network. Better scalability. Large networks where multicast traffic can become substantial. Think about the network here on campus. Lots of traffic running around here. Snooping helps keep the network scalability by ensuring that only necessary traffic is routed efficiently to the correct devices. Overall, IGMP snooping enhances multicast traffic management by reducing broadcast-like behavior. So you can talk to only those that you want to talk to instead of everybody. Definitely see the advantage to that. And then that is just a graphic that shows the difference between snooping and not. Pretty. So, in a nutshell, IGMP is a way for your network to minimize broadcast and make itself much more efficient. So, questions?
Hold on, I do have one question. Wait a second. This, this graph down here, it's supposed to show how exactly, the snooping works, right?
This graphic down here?
Yeah, this graphic down here.
Mm-hmm.
Okay, I still, It's still in.
Basically, without snooping, everybody talks to everybody.
Oh, okay, alright.
So it blocks the ports of,
And then with the snooping, you can block everything.
Okay, yeah, okay.
This computer here is not part of the multicast.
Yeah.
This computer here is not part of the multicast, but they're still getting the traffic.
Mm.
Over here, same two computers are not part of the multicast. But you notice that there's no arrow showing that traffic is
Okay, I get
being routed through.
it, yeah.
Good question.
Okay, so I don't know how well you guys can see this, but I'm well up over 13,000. Hey, there's an IGMP.
Packet.
Almost 20,000 packets. I've only got 3
That's insane.
IGMP packets so far.
Wow.
How does that, okay, so what does this tell us? Like,
so the
You
IP,
should run a membership query. So 1224001. Membership report for the group 251. Membership for the group 239-255-255-250. Whoever, well, 254 is going to be the router. I don't know who 125 is.
and so that's packets coming into your computer?
Wow.
Just packets sent over your network card? So what's this like membership query? Is that like your computer asking, like, am I part of the,
Or can I be?
okay.
because you don't have to act like, wait for time to leave or nothing in this IGMP tool.
Yeah, if you break these out, you can look at the data and see how they match up with
Okay, yeah.
with that. So that one was membership query, so there better be a hex 11 in there somewhere. Query. Right there.
Right there. Or just act like that.
Yeah, this 239-255-255-250. That's one of the static addresses that's in my ARP table. Two two four zero zero 251 is
That's a static IP address?
Oh, so
How does
you
it know
use
that it's a static IP address?
the Wireshark to confirm, okay, to make sure that you got your numbers right. Oh, okay, so where you can use the Wireshark and the command prompt to double check the numbers and, okay, yeah, that's neat.
Yeah, Wireshark monitoring everything that's coming across that wire, up to 122,000 packets that it has picked up. And out of that, there's what, a dozen IGMP? So apparently our network is using V2. You can do some really, really cool stuff with Wireshark. Lots and lots and lots of stun messages. OTCinstructor.com, that's Canvas. So, yeah, I really encourage you guys to, play with Wireshark. And just see what all the cool stuff you can find on it. But that in a nutshell is IGMP. And the protocol quiz. Don't have a due date on it, so I'll fix that. What's next Wednesday?
The ninth.
Okay, there we go.